Welcome to section 10.2. The domain and range is something that we talked about yesterday. So that should be fresh in your mind, but today we're going to introduce the idea of a function. A function is a relation where each element in the domain is paired with exactly one element of the range. If it's paired with more than one element of the range, that means it cannot be a function. But as long as it's only paired with one element of the range, we're okay. In other words, you can't have x's repeat. That's the simple way to remember it. Or you can remember all this other stuff. Can't have x's repeat. So, for example 1, 2, 3, and 4, they want you to state whether or not they are a function. So right here, when we list out our domain, we would have 2, 3, and negative 2. And when we list out our range, we have 0 and 4. So the question is there an x that gets paired with more than one y? Well, this x gets paired with just that. This x gets paired with just that, and that x gets paired with just that. And since none of our x's repeat, we don't have to worry about that, and yes, this is a function. However, let's say we came in here, and instead of it being this, and notice that here we have 4's that repeated. That doesn't matter. How many times we use a y does not matter. What matters is the x's. Let's say we had the number 3, 0 in here. Once I introduce that 3, 0, now I have 2 x's. This x gets paired with 4, and the exact same x gets paired with 0. We can't have that because each element of the domain has to be paired with only one element of the range. Since this is paired with 4 and with 0, that's what would make it not a function. But this one wasn't here, so we're not going to talk about that. Looking at this one, do you think that that is a function? Yes, it is a function. If you need to, you can separate out and write out all the ordered pairs, and that'll make it easier for you to see. 2 gets paired with 4, but it's only ever paired with 4. 1 is only ever paired with 5, and 0 is only ever paired with 5. It's okay that 5 gets used more than once. That's not the issue. The issue is, are any of your x's used more than once? If we had come in here and had our 2 going to the 5, that's what would make this not a function. Or had our 1 going to the 4, that would make it not a function. But we didn't have that, so I'm going to take it back out. But it's when two things are coming for the x is connected by 2 lines, that's when it's not a function. This one, yes, it is a function. Over here, when you're looking at graphs, you're going to have to use the vertical line test. This is the vertical line test. Yes, you're going to have to memorize this, so sorry, but you will. If you can draw a vertical line anywhere in your graph and it touches the graph more than once, then it's not a function. So, if I go through, vertical means up and down. If I go through and I draw some vertical lines in here, it only touches it once there, it only touches it once there. If I come over here and I draw a vertical line there, it's only going to touch it once there. So there's no time it's going to touch it more than once. So that makes this, yes, it is a function. It's okay to touch it one time. It's not okay to touch it more than one time. Over here, if I start drawing vertical lines in here, I could draw one over here. It doesn't touch it at all. That's cool. I could draw one right here, and it's only going to touch it once there. That's fine. But as soon as I get over here, I have it touch it down here and up here. That's twice. That twice is more than once. So, no, this is not a function. Yes, it is a function. No, it's not a function. Now, we have talked about being able to tell if things are functions or not. But we haven't really talked about how to write a function. So we're going to talk about that next. Function notation. This is an example of what function notation looks like. The F is referring to a function. The F doesn't have to be an F if you don't want it to be. It could be a G or an H or a K or a P or a Q or etc., etc., etc. But usually they use an F because this is function notation. This is read F of X equals 2x plus 3. So that's what you say. You say f of x. What we're talking about is really not even f of x. If you can keep in mind that f of x is the exact same thing as y, and y is the exact same thing as f of x. They are the same thing. They are interchangeable. All that this tells you is that it's actually a function. So if you were to graph it, it would pass the vertical line test. That's the only purpose for writing it like this, except what I'm getting ready to show you in a minute. So when you see it, you can think of it as y equals 2x plus 3. That makes a lot more sense to you. You can do something with y equals 2x plus 3. So a lot of times when we say something like f of x equals 2x plus 3, what we're really thinking in our heads is y equals 2x plus 3. I see them interchangeably all the time. Kind of like a minus and a negative are the same thing. So you have to be able to switch back and forth and not be freaked out by it. This is the same kind of thing. You have to be able to switch back and forth between the f of x and the y. Just a different notation. It's a different way of writing things. Now, they will ask you to evaluate. It's a different problem, but sometimes they'll want you to evaluate. F of 2 when f of x is equal to 2x plus 3. If they want me to find f of 2, I have to start with my f of x. My f of x is really 2x plus 3. But if I want to find f of 2, what changed on this side of my equal sign? We switched out the x for the 2, right? Well, that's the same thing I'm going to do on this side, because if you do it on one side, you got to do it on the other. So that becomes 2 times 2 plus 3. So that means that f of 2, it's not that I'm multiplying these, because remember this is just another way of saying y. So I'm not going to multiply these or do anything on this side, I'm just going to work on this side. So 2 times 2 is 4 plus 3 gives me 7. So that means that f of 2, which is what I was looking for, is equal to 7. So 7 is my answer. Another way to think of it, and this one's going to hurt you just a little bit. Another way to think of it is when we put a 2 in for our x, we get a 7 for our y. Because that's what happened. When we started doing f of 2, we got 7. So that's like y equals 7 when x is equal to 2, which is how some places will say that this is the point 2, 7. They'll go ahead and write it as a point. Now your book doesn't want you to do that. Your book just wants you to come out with the 7. But this is kind of how we're going to have to see it when we get into Algebra 2 and when we get into pre-calculus and on down the road. We kind of have to start seeing it as an ordered pair. So when we replace 2 for our x, we end up with 7 for our y. Now your book is just asking for the 7. So just like yesterday, they're going to ask you for some domains and some ranges, just like we've seen so far. And then they're going to ask you for you to evaluate some of the things. Let's see. Page 419 and 420. 1, 5, 9, and 13. This is in the practice exercises. And then the homework. 3, 7, 11, and 15. And that should get you through section 11-2. And we will do, section 10-2, and we will do section 10-3 next week. Or, might not be next week for you, might be in a couple days. But in a little bit, we'll do section 10-3. Okay, bye.